All right, welcome back to trigonometry. We have some conversions here. We are going to convert from polar to rectangular and vice versa. So the instructions say we're going to convert the rectangular coordinate, -2, 2 root 3, to polar coordinates. My advice is graph them. Before you start converting, just graph them so you can make sure that you're doing this thing in the right way and you get the same points either way you do it. So -2, 2 root 3, 1, 2, 1, 2, 3, and then some. It's going to be up here somewhere, okay? So I need I need a polar coordinate point that's going to point to that point up there, that spot up there. Okay. So, oh gee, hey, that looks like a triangle. And I have a -2 here, and I have a 2 root 3 up here. Now, so I have two legs of a triangle, and I'm trying to figure out the hypotenuse and the angle of this triangle. So I want to know that angle, right? And I also need to know the hypotenuse. Well, if we go ahead and figure out our hypotenuse, we're going to say that r squared is equal to the square root of -2 squared plus 2 root 3 squared. You will have a calculator to do these. I don't really have an issue with the fact that you guys need a calculator for this. That's fine. So we're going to say this is r squared is equal to -2 times -2 is 4. Here we have 4 times the square root of 3. So we're going to have 4 times 3 sitting here, okay? So that's how we're going to do that. Okay, again, a calculator is going to give you the same answer provided you plug it in correctly. So I have r squared is equal to 4 plus 4 times 3 is 12. So we end up with the square root of 16, which is 4. Okay, so we have 4 there. Now, for my angle, right, we're going to say, well, let's see here. I have an opposite and I have an adjacent. What trigonometric ratio relates the opposite and the adjacent to the angle? And it's like, well, tangent, of course. So we say tangent is equal to 2 root 3 divided by -2 because we're on -2 here. And we can say, okay, well, that's going to be tangent of theta is equal to the negative square root of 3. And we can go ahead and start plugging some of that stuff in. So we're going to check to make sure. Are we in the correct mood? So I'm going to say you can do this in degrees. That's fine. Okay. So what we're going to do is we're going to take the inverse tangent of the negative square root. Let's see, where's square root? There it is, of 3. And what are we going to end up with here? Okay, let's see what we have. Look at that. We'll say -60 degrees. Where is -60 degrees? Well, that's down here, isn't it? I don't want -60 degrees. I want something in quadrant 2. So what do you say? Why don't we add 180 to this and we'll end up with 120 degrees. So my conversion is going to be 4 comma 120 degrees. And that's my polar coordinate for this Cartesian coordinate. Okay, we end up with the same location, the same geographical point when we do this thing. Okay, let's look at the next one. So we have -3, 7 pi over 6, and we're converting this to rectangular. Okay, so that's great. Again, when you're graphing polar and rectangular, we're going to go ahead and graph it first. So I want 6 pi over 6, which is going to be here. I want 7 pi over 6. So I want this angle. And now, once we know what angle we're facing, we're going to travel backwards. 1, 2, 3 points. So wherever I end up with, we'll call this B. We should have called the first point point A, but we'll call this one B. So when I plug this thing in, right, we're going to be able to say, well, I need something that's going to be in quadrant 1. So my angle is 7 pi over 6, and my value is -3. So how I'm given a hypotenuse and I'm given an angle. How would I get the adjacent side? How would I get the opposite side? So it's like, oh, adjacent side. That sounds like a cosine. So I'm going to say that cosine of theta is equal to opposite or adjacent, not opposite, over my r, or over hypotenuse. So we could say the adjacent side is x. So we could say cosine of theta is equal to x over r. So r cosine theta will be my x coordinate. We're going to do a very similar argument for sine, where this is going to be opposite over r. So sine of theta is equal to the y over the r, the opposite side. So we have r sine theta is equal to my y. Okay, so we can go ahead and start looking at that. Now, one thing I do want to do before we start is to say, oh, what's the reference angle for 7 pi over 6? Isn't it just pi over 6? Like, yeah, it is. So we can go ahead and deal with it this way. So I know my hypotenuse, which was going to be 3. So it's, you could say the hypotenuse is 3 because we've changed the reference angle. We've changed the angle. So we're going to say 3 is my r, and my angle is pi over 6. So to get the x coordinate, that's going to be 3 cosine pi over 6. My y coordinate is going to be 3 sine pi over 6. We're just going to plug these things in and get our values for it, okay? So we have 3 times cosine, and we'll go ahead and we'll say pi, there we go, pi over 6. You know what I have to do still, though? We have to change our mode to radians. Okay, otherwise we're not going to get the right answer. So be careful about that. Okay, so we have an equals. We have 2.59. We'll say the 3 decimal places. So we have 2.5, and what was our value here? 2.598. Okay, 2.598. And I think that was our cosine. So this is our x value. Let's move this 2.598. Let's get rid of it over here. Okay, so just make sure we're putting the x where the x's should be. Okay, put the y's where the y should be. So here we're going to say this is 3 times the sine of pi over 6. So here is pi divided by 6. Again, because just we're looking at the reference angles. So I don't have to do that. And we got, oh, I didn't want 3. I wanted 3. I put down 0.3 here. So we actually end up with 1.5. Okay. So if I wanted to graph my x and y coordinates, here's 1, 2, 1, 2, 3. Okay. So we have x is equal to 2.59. So here's 3. So we're going to be about here. And then y is going to be 1.5-ish. It's about right there. And that is looking like the same kind of point that I got there. So my answer here is, 2.598, 1.5. I guess you could add a couple of zeros in there if you'd like. Okay, but that's part B. Okay. Part C says we're going to go ahead. We've got the angle. We've got the polar coordinate. Let's see, where are we? 2, 2. Okay. And we're going to go ahead and figure that. So we've got to say this is 2, 2, and we're changing it to polar, or changing it to rectangular, rather. Be careful about this because this looks like a rectangular coordinate, but it's not. It's polar. It's like, well, where is 2? 2 radians. Well, I know that 1.5-ish radians, 1.57 radians is pi over 2. So it's going to be a little bit beyond that. It's going to be over here somewhere. And then we're going to need 1, 2 to get over here. Okay. So again, we're going to say that we have, this is my r, this is my theta. So to get the x, we're going to say x equals 2 times cosine of 2. Y is equal to 2 sine of 2. And we'll go ahead and make sure that that's going to work out. First off, are we in radians? We sure are. So go ahead and quit out of that. So we want 2 times cosine of 2. And it's going to be a nasty decimal number here. So we end up with negative 0.832. So this is negative 0.832. Okay. And then the second one, we have 2 times sine of 2. All right. So we end up with 1.81, or I'm sorry, 1.819. 1.819. So when I go to graph this, we have a negative value for our x. We're going to be going over here. And then 1.899, we're going to be going up. So again, I'm going to be getting approximately the same geographical coordinate. So we can say, okay, this is comma. Let's see what we have here. Negative 0.832, comma 1.819. And that would be my equivalent coordinate in rectangular going from 2, 2 as polar. Okay. So sometimes they look a little tricky, but as long as you try to remember, like, okay, am I in polar, I'm going to rectangular, or I'm in rectangular, I'm going to polar. Draw the triangle, graph it. You won't go wrong if you go ahead and just sketch yourself an answer for an idea, and then you'll be okay. Okay, I'm going to say thank you very much for watching the video, and I'll see you in the next one. Okay, take care.